What is up, Web3 people? Welcome back to the Moralis channel. Today we're taking a look at how you can build a decentralized Web3 social media profile like you see on the page right now. And why this is so cool is because anyone can check that this user, alum.eth, owns all their social media presence on the blockchain, and no Web2 giant has this data on their centralized servers. And how we're going to accomplish this is we're going to use something called Lens Protocol, which is essentially a back-end solution for storing social media data. You can create a profile or a post, and because you own these social media elements on the blockchain, you can associate some fees with it. For example, if someone wants to collect your post as an NFT, they might have to pay a fee for your post. And one cool feature is the follow functionality. You can provide fees for people to follow you if you like to avoid any spam, or you can provide prizes for followers. And these prizes, for example, could be NFTs. And say you want to say that the first 100 NFT holders for your followers can generate a DAO. So future proposals you create can be governed by your followers themselves. And why this is so cool is because we can integrate it with Moralis, which provides enterprise-grade Web3 APIs where you can then query all this data that's happened on the Lens protocol and generate fantastic user interfaces. For example, for alum.eth over here, we can see all the profiles that have provided alum follow NFTs for him following their Lens protocol social media profiles. And alum.eth over here has provided a follow me functionality where he says that, hey there, give me a follow and receive this cool NFT. So you will receive this NFT showing that you follow alum.eth on Lens protocol if you follow them. So if we press follow, this prompts a MetaMask interaction where we send a small fee, which is just gas, to the smart contract to follow alum.eth. We confirm this. The follow has gone through, and now let me just open up OpenSea, for example. All right, I've come to my profile over here on OpenSea, and we see that Suniri888 Lens follow NFT. This is that NFT, nice, and we are now a follower of this user on this decentralized social media graph. How cool is that? Stay stuck in, and I'll show you how to build this.
Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
All right, starting here in our IDE Visual Studio Code, I have this repository called Web3 Profile Starter. The link for this GitHub repo will be in the description below. You can go ahead and clone this repository, and then once you get it, cd into the correct repository and run npm i to install all the dependencies of this project. All right, that's done, and I've initialized this project so that you should be able to run a development server, npm run dev, straight away, which should open up localhost 3000 or 3001 if you have another development server running at the same time, and you could go check out what the starter repo looks like straight out the box. So open up Google Chrome, and as you open up localhost 3001, you should get a page looking like this. So we have a default banner, a default image, and default information about the user, and we have the tabs that the user can select from. Of course, we're going to build out the NFT functionality for following a user on Lens protocol. So that's why we only have these tabs created, but you could go ahead and add to this project by using Lens protocol to scan for the posts this user has made on Lens protocol. But this is a great starting point for us to now go check out how we can use Lens protocol to query for the user's details. All right, so first let's jump into the Lens protocol documentation over here, which they have extensive documentation, which is great. And we're going to be working with the Lens API, which allows anyone to use the GraphQL API to query for various details that are stored on the Lens protocol smart contracts. For example, the profiles, reactions, publications, timelines, and so on and so forth. But first, to be able to use their protocol, let's check out querying from an application. We'll be using URQL, which is a React client for GraphQL. And check out over here what we need to do to expose the client. So essentially what this is, we're going to make a backend endpoint that creates a GraphQL client for us to query all the public API endpoints at this URL. This is of course for the Mumbai testnet, but we'll be using the Polygon mainnet. Then in our client side of the application, we can create a query where we actually define what we want to search for. So are we searching for publications or profiles? And then by using this line over here, we wait for a URQL client to query. This query we set up, and then by indicating it's a promise, we get the response that we can then present in our front end. If this sounds good, let's jump back into Visual Studio Code. Let's actually copy this out and jump back into Visual Studio Code, jump into our pages folder. Let's close up our terminal, and in our API folder, create a file called lens calls.js. And in here, we can paste what we copied over from the documentation. And rather than using the Mumbai testnet, let's actually use the mainnet URL. So jump back into Google Chrome, check out the API links, and we're going to be using Polygon mainnet. So copy over this one, jump back into VS Code, and paste it in here, like so. Save that. And now what we can actually do is we can define our query over in here to avoid clogging up our client-side code. So let's go check out what we want to query for. Jump over here, and we're looking for profiles. So let's open this up, and we want to get a profile. So this documentation shows us how to query for a profile. And here is an example operation for querying for a profile. All you need to provide is a profile ID. And then if you're familiar with how GraphQL works, you can actually select which attributes you want to actually get back from the response. We'll just use all of it for this example. Let's go over here and copy this, jump back into Visual Studio Code, make sure we export our query, export const profile equals, and inside these parentheses, we'll paste the whole query we copied over from the Lens protocol documentation. So this will give us the profile information for profile ID 1. Of course, in this case, you need to know which profile you're looking for. You could use some of the other endpoints, like getting recommended profiles, for example. This endpoint would give you a list of profile IDs for recommended profiles, but let's assume that we already know which profile we're interested in, and for example, search for profile ID 9. Save that, and now we have this backend endpoint we can call in the API folder, and we can jump into our index.js file, which has the full front-end build of our project. This is what you saw on the localhost 3001 or 3000, depending on which server you're running on. And in here, we can go over and get server-side props to run this lens calls endpoint and get our profile information. So let me show you how to do that. Over here at the bottom of the script, let's get our server-side props by awaiting our URQL client to query for our profile. So we set these over here, our URQL client over here, we initialized, and then the profile is over here. So we have to make sure that we also import them into this index.js file, like so. Save that. And now our server-side props can also return, and then we get some props where we can get a profile, which is the response. Make sure we have it and get the data.profile. Seems like we misspelled response, like so. That is good. Now our server-side props are returning these props profile, which we can then get in our home component, which is basically our whole app, get our profile. And every time we render our home component, we can just console.log our profile information. So for now, we can see what is stored in this profile object. Save that. Make sure everything is correct over here. Seems like this was misspelled. So we have the profile returned, save that. And now you should be able to go check out your development server, jump into Google Chrome. You have this, make sure you refresh. So we get those profile details in our console, inspect console, and look at this. We have our object, which has the buyer for this user, the cover picture stored in the original object on the URL. Then we have their handle, we have their user ID, we have their name, and so on and so forth. We also get their follow NFT address. So this is the address of the NFT that users who follow this user will receive. So we have all this information about the user we can now use to populate all these informations and eventually also populate all the NFTs this user holds for following different users and the NFT that they give out when people follow them. So let's go ahead and populate first their information over here into the left bar and the cover photo. Jump into Visual Studio Code, scroll back up, and over here we can start off with a cover photo. Let's remove the default photo, and now from our profile object, get the cover picture original URL. Same thing for our profile image, remove that, get from our profile object the picture original URL. Then for our name, we can do all this. Let me just fill the name, handle, and bio quickly, like so. And then the final thing will be the followers, which is stored in the stats object. So let's import the total followers here and the total following here. Boom shakalaka, that's it. Now go check out your development server and look at this. Now we have nicolo.lens. This is Nicolo's profile. We get their cover image, we get their bio, their handle, the amount of followers they have, and the amount of people they are following. All this is cool. We can even check out changing the user ID. So let's go over here to Visual Studio Code, jump in to our API folder, lenscalls.js, and change the profile ID. I don't know, let's go for example, 81. Save that. And now if we jump into Google Chrome, refresh the page, look at this, now we get alum.eth. How cool is that? We get their details. What we have to do now is go ahead and check out the console and check out this user's profile object, and we get their wallet address. And now this wallet address we can use with the Moralis NFT API to get this account's NFTs on the Polygon network that have .lens NFTs, which will then refer to the follow NFTs we're looking for. This will make sense once we start doing it. So jump into Visual Studio Code. Make sure in your env.local.example file, you change it to env.local and you get a Moralis API key. In the starter repository, there should be a link to where you can get your own. This is your private API key. You shouldn't share to anyone. I just have an example over here. So make sure you have that, and then jump back into your index.js folder and we'll start making some Moralis API calls. First of all, you'll of course in the start have to import Moralis to your index.js file, like so. Save that, then scroll all the way down, and where we get our response, now let's go ahead and initialize a instance of Moralis with our Moralis API key, like so. So all you have to do is await Moralis to start with your API key, which should be stored in your environment variables. Save that. And now let's go check out the Moralis documentation to see how we can query for an account's NFTs. Jump into Google Chrome, go to the Moralis documentations, and here we have the get NFTs endpoint. We have this cool representation of how to handle it. And all we have to do is wait for the Moralis EVM API account endpoint to get NFTs for a specific address and chain, and then we'll get a response. So this shouldn't be too hard. Let's go ahead and jump back into Visual Studio Code. Rather than calling it response, because we use that for our Lens protocol query, we'll call it balances, and we get our NFTs. And as the address, we use from our response the owned by attribute from the profile. So we get the owner's address, and then we're using the Polygon. Because Lens protocol is on the Polygon mainnet, we're going to use the chain ID for Polygon. You can check that over here. If you have chains, we see that Polygon's ID is 0x89. Jump back into Visual Studio Code, and now in our balances, we have a response of the NFTs on the Polygon network this user owns. But we want to do a little bit of filtering to just get the Lens protocol NFTs. So let's go ahead and create two variables. We'll make a NFT array and an NFTs which has the result of our Moralis get NFTs query, which is an array of all the details of every single NFT on the Polygon network this wallet owns. And now we can do a little loop. This will be in the final repository, so you can check that out from there. Well, let me just paste it in over here, like so. So we check out every single NFT in the NFTs array. We make sure that the NFT has metadata. And if it has metadata, the Lens protocol NFTs are stored in an attribute called animation URL. So we check that there's an animation URL. We check that that animation URL isn't null. And then we make sure that the animation URL includes .lens, making sure that it is a Lens protocol NFT. And then we push them into the NFT array, which we can then pass as props to our component. So we return another prop called NFT array, and it'll be the NFT array, like so. So now we're doing this on the server side. Let's make sure we pass it to the home component over here, NFT array. We can remove the let NFT array declaration of a variable over here. And now everything should be done in the front end over here. If you scroll to tab 1, we are looping through the NFT array and mapping the animation URL as a source for an iframe. So everything should be done for you. You can go check out Google Chrome on your development server. If you refresh the page, you should start seeing NFTs of the following for alum.eth pop up. How cool is that? And all these interactive NFTs. This looks awesome, awesome, awesome. And all we had to do is make a simple call to the Moralis NFT API, and you're already making a wonderful user experience for your users. Now, finally, let's do the follow me. So we have the follow NFT address as well. So we can use the Moralis NFT API to get the details for the NFT that users will get for following alum.eth. So let's go ahead and do that quickly as well. All right, before we jump into Visual Studio Code, let's go check out the Moralis documentation to see which endpoint we're going to use. We're going to use this endpoint called get token ID. It's under the token method, and we scroll down to the bottom, we get token ID metadata. So if we check out over here how it works, we use the EVM API, the token method, and the get token ID endpoint. All we have to pass as arguments is the address of the NFT smart contract, which we have already from Lens protocol, and the chain, we know it's Polygon network, and the token ID, we can just use the first token because it should be the same NFT that is provided for all the followers. So now if we jump back in to Visual Studio Code, we already have imported Moralis and we have this functionality in getting our server-side props. So we basically have to make a similar call as over here we did with the user's NFT balances. Let's add it over here above our return statement. Let's create a variable called follow NFT, which awaits for the Moralis EVM API token method to get our token ID metadata endpoint with the follow NFT contract address, Polygon network chain ID, and the token ID 1. Now all we have to do is parse the metadata that we get from the response and then select the animation URL, which will be the source for the image we present on our front end. Do it like so. My NFT, we parse the metadata and we get the animation URL attribute, and then we can pass those as props. My NFT will be equal to my NFT. Save that. So now the server is getting the follow NFT and we can pass it to the home component as a prop, my NFT. We can remove the declaration from the component itself because now we have it as props, and you can see over here in tab 2, as long as we have an NFT, we're rendering an iframe where the source is the NFT itself. So jumping into our development server here on localhost 3001, refresh the page. It should take you to the first tab like it did here. But now if we select the second tab, now we are rendering also the follow NFT. So users know if they press this follow me button, what NFT they get as a reward. How cool is that? Of course, this follow me button isn't doing anything now, but we can quickly add using WogMe functionality where the user is prompted to sign in with MetaMask and actually send a interaction to the Polygon network to follow this Lens protocol user and receive this NFT as a reward. Let's add that now. Jump back into Visual Studio Code. Let's just start by scrolling up and importing what we need from WogMe. So we're getting a few hooks, and then we're getting the MetaMask connector. And then we also have this file called abi.json in the repository itself, which has the contract application binary interface for the Lens protocol on the Polygon network, so we can actually interact with the smart contract. I'll show you more about this very soon. What we have to do is then destructure the functionality from our hooks like so. So we're getting connect to sync, disconnect to sync, and is connected. And now let's go ahead and before we prepare our smart contract writing functionality, let's check where we're going to write to. Jump back into Google Chrome, go to the documentation of Lens protocol, and check out the deployed contract addresses. So we have this contract address 0xD46, which we need to use for interaction. So this is the contract address you will use for interacting with smart contracts. But for the implementation, we have to check out this address where you check out the contract here on Polygon Scan and scroll to the bottom. This is where we get the smart contracts application binary interface if you're curious on where it comes from in the repository. And we can go ahead and look at the functionality we can use in the smart contract. Let's look at writing the contract. If we scroll down over here, the 11th function is follow. It takes in two arguments, an array of profile IDs and then an array of bytes. So why Lens protocol is cool is because you can define as a profile owner information, for example, a fee that is required to follow you or a time period that has to pass, and that would be passed here in the data's object. We'll only be following users where no additional data is required to actually follow them. So you can pass empty data. So this is a bit outside the scope of this video, just important for you to know that why we're passing two arguments to this follow function. But now, as we know what we need to call on the Lens protocol functions, let's jump back into Visual Studio Code and prepare using WogMe our contract write. Like so, we use the use prepare contract write hook where we get a configuration object. And here we pass the address that we need to call for the Lens protocol. We looked at this a while ago. Then the contract interface is the ABI we have stored in the repository. And then we're using the follow function. And as the arguments, we're passing the profile's ID. And then again, here is that empty data object that we talked about that is slightly outside the scope of this video. Now, what we can do with these prepared contract write information, we can actually set up a function that will allow us to interact with the smart contract. So all we do is we pass the config object to the use contract write hook, and we destructure the write function. Now, this write function will write with these details to the Polygon network as long as we have a signer. So in our follow function, we have to check that the user is signed in, and we can do that with WogMe. We first check if the user is connected, we await for them to disconnect, and after that, we make sure they connect, await for asynchronous connection using the MetaMask connector, and after the user is connected, they can use the write function from use contract write hook, like so. We're writing onto the smart contract with the details provided over here. We're doing the follow function to this smart contract address with these arguments. So we're following the specific profile ID that is showing on the page and sending no data also. So we save that, and now we should have a functioning follow function. And this follow function is triggered on the press of the button. Just for you to make sure you know where it's happening, we have a button over here, and on click, we run the follow function. So now if we save this, everything should be working. Jump back into Google Chrome. Here we have our local development server. Let's press follow me. I already did this at the intro, so I won't actually go through with it, but let me just show you. Pressing follow me prompts up MetaMask. We're sending a transaction to this address with follow. I don't have any funds on this wallet, but you saw this at the start of the video, so you can check out the functionality there. But this will then follow you to this address and provide you with this NFT. How cool is that? We created a decentralized profile page with Lens Protocol and Moralis. There's a lot more you can do. You can look at the social posts, the publications. You can look at a follower count. You can look at recommended profiles. You can do all sorts of things with Lens Protocol and Moralis. I hope to see you build some cool things with this. I'll catch you in the next one.